think 11b is the first one for which you actually have an inner and an outer radius. I take this region right here, and I revolve it around the y-axis. So I revolve it around this thing right here. So that's going to spin it like this. All of these pieces are going to spin around. Yeah, I don't want that one there. So I'm going to get a replica of this over here. And then there's going to be a connector piece out around the end. And then there's going to be another connector piece. I'm going to do it dotted around the top. And then like there's going to be a little piece here, right? So you can imagine like it's almost going to be like a bowl-ish shape, but like pointy. It's hard for me to describe. But basically I have the outer radius, and that outer radius is, change colors. So this is going to be the outer radius. You can imagine when I take that part right there, when I do that disk, it's actually going to be not a disk, but instead it's going to be, you can imagine, I'm going to see it like that if I were to look down on it. So the piece that I just drew that dark green line for would be that right there. And you should see that that is this length, which is 4. So I like to say that the big R is 4. And now we have to figure out what the small r is. So the small r is going to be this length right here. Now, sometimes these are tricky to figure out. I've got the big piece is that 4. The little piece, I'll do it here too. Well, that's the x value of this graph right here. So I'm just going to write little r equals x for now, and if we have to change it, we'll deal with it. So now I want to figure out if it's dy's or dx's. So if you look at this, my disk that I drew right here is kind of there, and if I were to put another disk, it would land above it, right? So, or if I were to do the lowest disk, it would be this piece all the way down here. So those disks are dy's. What I mean, they would be stacked on top of each other instead of being stacked next to each other. So I've got a dy. I've got a dy for this problem, which means that this thing right here, this x, is not going to be good because I'll write it out. I'm going to do integral. Let's fill in the numbers. If I'm doing dy, that means that I've got my slices like this or like this. So I'm going to go from this low point of 0 all the way up to the high point of 2. So from 0 to 2, v equals, put the pi out front, times r squared dy. Now, I kind of talked about this in the video for 7, but if I try to plug in this x right here, the radius is x. If I try to plug in the x for my r squared, or for my r right there, I get x squared, but I can't integrate that with respect to y. So what I need to do is think about this red graph right here. I know that I want to do the x value of that, but I want to write it in terms of the y's. So I know that that graph is y equals root x. So if I square both sides, I get y squared equals x, right? And that x is my radius. So what I'm going to do is plug in this value of x of y squared for x. So I get r equals y squared, which then I get pi integral 0, 4 2, not 4, of y squared squared dy. Oops. You know what I did wrong? I didn't deal with, oops, I didn't deal with the inner and the outer right, but everything else that I said so far has been fine, so I'm not going to change anything. But this shouldn't be that. It should be pi times the integral from 0 to 2 of big R squared minus little r squared dy. Now I can explain that a little bit. If I was trying to find the area of this thing, and you should be okay with this based on what we did in class, if I was trying to find the area of that thing, I would do the area of the bigger circle minus the area of the little circle. So that's what we're doing here. All right, so anyway, I get that that is equal to pi times the integral from 0 to 2. I need to give myself some more space. So my big R is 4, bracket it, 4 squared, minus, my little r is y squared, so I get y squared squared dy, which gives me pi times the integral from 0 to 2 of 16 minus y to the 4th dy, which I'll just carry down. That gives me pi times, now I'm going to integrate, that gives me 16y minus 1/5 y to the 5th power. And I need to evaluate that from 0 to 2. Well, the 0 is nice. That's going to go away. I get pi times, 16 times 2 minus 1/5 times 2 to the 5th. And then I subtract 0 plugged into that thing, which is just 0. And then from there, you could work it out by hand, or I might use a calculator to do this calculation, that 2 to the 5th, and all the addition and stuff, just for time's sake. I get pi times 32 minus 32/5, which comes out to be, and this I would definitely use a math frac, I think, for my calculator. I don't think it's worth it to do this by hand, so I would get 128 pi over 5, which in a decimal form is equal to 25.6 pi. So it's really a matter of setting it up, figuring out, first off, that we have the big R and the little r and dealing with it, right? Then figured out whether it's a dy or dx. We figured out dy. Then figuring out your radius for each of them, writing them in terms of y. This one didn't have to get adjusted because that was constant, right? And then plugging those values of r into our equation / formula that's kind of like the volume of a cylinder. And then just from there, it's just doing integration and power rule and stuff like that. And being precise with your calculations.